I'm glad I can bring a little humor to you today, but Dr. Farmer is our next speaker. She is a research scientist in sow lactation biology who has been working at the Sherbrooke Research and Development Center of Agriculture and Ag Food Canada since 1986. She obtained her BS from McGill University, her master's from the University of Saskatchewan, and her PhD from Penn State University. Dr. Farmer was a pioneer in studying mammary development in gilts and sows and intensifying the various factors affecting it, identifying those factors. Thank you for joining us today, Chantel, and your clicker should be working appropriately.
Thank you. Some of us are not too good with electronics. Is this working? I guess I got to put something on here.
It's on the top.
Yep, that's going to be better. There we go. Hide this. Well, thank you, Mr. Chairman. It's a pleasure to be here. I think I've been in Iowa once in my life, maybe 30 years ago, so I can barely remember any of it. So I hope I have some time later this afternoon to go walk around because it looks beautiful. Very nice campus. So it's a pleasure to be here today and to have this chance to talk to you about feeding gilts and sows to maximize their mammary development. I'm going to start by telling you something I hope everybody agrees with here. The sow is just amazing. When you think about it, at peak lactation, a sow can produce more milk per kilogram body weight than most dairy cows. That's a lot of milk. However, poor sow, she's already producing a lot of milk, but she's not producing enough. And this was made worse now with our hyper-prolific sow lines. She's got more piglets, and each piglet is actually drinking less milk than about 10 years ago. It's not her fault. She's producing more milk, but she's not catching up with the increasing litter size. So when I see people from genetic companies, I say, please stop selecting for litter size and start selecting, which they are doing. I've sent a message, and I'm not the only one. I know Mark in the other room is sending the same message. Look more at weight, at weaning, total weight. Make sure that you don't focus on litter size per se. All I want to say is when you have a baby pig and it's suckling from the sow, and on top of the milk it's receiving from the sow, you give it milk from a bottle, artificial milk, it'll grow more. So what is it telling us? The growth potential of the pig is not achieved. Why? Because the mother is not giving enough milk. But let's not blame her too much. She's still doing a lot. But we have to help her because we're asking her to do so much with these great litter size. So what have we done? We've done a lot of research, mainly in lactation, looking at nutrition. Yes, we need to maximize feed intake. Yes, we need to maximize intake of specific nutrients during that crucial period of lactation. However, can we do anything with nutrition to help the sow before she starts to give milk? And then one way that we could look at to achieve this is trying to find nutritional strategies that will stimulate mammary development. And that is to achieve a maximum number, or the greatest number possible, of milk-producing cells at the onset of puberty. Of lactation, that would be better. Why do we want more cells? Because it was shown that a main factor that does limit milk yield is the number of secretory cells present in mammary tissue when the sow starts to give milk. Makes a lot of sense. The more cells you have that can produce milk, the greater milking potential. Just goes hand in hand. Now that you know why we're interested in mammary development today, let me tell you what I will cover. Well, you need to have a little bit of background to see where we're heading with nutrition. So when does mammary development take place? What are some of the hormones that affect it? Estrogens, prolactin, the growth factor, insulin-like growth factor 1. Why do I bother with hormones? Because some of these hormones will affect nutritional interventions that we can use to stimulate mammary development. Then nutrition, we will talk about it specifically before puberty, in late gestation. And I will focus on 2 projects I've done with supplementary lysine in that late gestation period. And I will end with some talk about body condition and does it affect mammary development, and can we do anything with body condition either at the end of gestation or at puberty, to affect mammary development, and end with conclusions. Mammary gland, here you go. Sorry, people on the other side. I will have to favor the ones on the right, but then I'll move to the other side. Okay, so here's the mammary gland, cross-section. In the teat, you have two ducts, two lactiferous ducts. You milk a sow, you get 2 streaks of milk, life is good. If you get 3, please keep your animal. A producer once asked me that at the end. Yeah, but how come I had a sow once with 3 streaks of milk? And I said, did you keep her? He said, no. I said, sorry, you'd be rich. Because if you could have 3 streaks of milk, things would be better. Anyway, 2 ducts. These ramifies into ductules. At the end of the ductules, you get alveoli. Around the alveoli, you have epithelial cells. Those are the good cells that synthesize milk. What I want you to remember from this are the 2 words in red. Parenchymal tissue is the good tissue where the milk synthesizing cells are present, the epithelial cells are present. The extra parenchyma is actually the fat layer around the mammary gland. You will see those names quite a bit, so you have to remember. The parenchymal tissue is a good tissue. The extra parenchyma is really the fat around the mammary gland. So when do we have any mammary development taking place? Well, at birth, baby pig, sorry, I should have had some water, has mainly stromal tissue in the mammary glands, very poorly developed duct system, so makes a lot of sense. It doesn't have to produce milk yet. You have 3 stages of rapid mammary development. Before puberty, starting at 90 days of age to puberty. Last third of gestation, starting around 90 days of gestation. So now you can catch that 90 is a number you need to remember when you leave here. So 90 days of gestation up to farrowing. Then obviously in lactation, the glands are being used, so they're being stimulated and they grow. However, as a scientist, I'm mainly interested in the first 2 periods because I want the sow to start lactating when she already has an optimal number of cells that can synthesize milk. So I will focus on these 2 periods. Then in red, during these periods only. 3 times 0 gives 0. If there is no mammary development, I don't care what you're going to feed that animal, what hormone you're going to inject, whatever you're going to do to her, she will not have more mammary tissue. When she does have some mammary development taking place, you can steepen the slope through hormones or nutritional interventions. And that's why those periods are really important. So when we do nutritional or hormonal studies, we have to focus on the periods from 90 days of age or from 90 days of gestation. Hormones. Which ones are important? What do they do? Those are the 3 that are mainly important. I will cover them a little bit. Estrogens, well, when the animal reaches puberty, you start to see estrogens coming into play. And then what happens, if you look at mammary tissue of an animal that's pubertal compared to not pubertal around the same age, then you see a significant increase in this good parenchymal tissue. Anytime you will see a number in red in my slides, it's statistically significant. So significant difference here, more parenchymal tissue when the animal has reached puberty, in presence of an important duct system, and obviously it's linked to the presence of estrogens starting to do their job. In gestation, it's the fetoplacental unit that's producing estrogens, and interestingly, you have a correlation between the concentration of estrogens in the blood of the sow on day 110 and the DNA. So DNA gives you an idea of the number of cells. So the DNA in the mammary parenchymal tissue. And these authors have said, okay, yes, so we know that estrogens have a positive effect to stimulate mammary development in late gestation, and it could be via receptors for prolactin. Okay, what do we know about prolactin? In 1945, it was shown that if you feed barley ergots, 0.5 or 1% in the diet, for the last 25 to 87 days of pregnancy, so 2 different trials in sows, you see almost no other development. Agalactia, no milk being produced. At the time, nobody knew why. So they said, okay, don't feed ergots, but we don't know why. In the 1970s, the radioimmunoassay to measure porcine prolactin was developed. Then they looked at what happened in the blood of these animals. Inhibition or great decrease in prolactin concentrations. So yes, the reason for this negative effect was because there was less prolactin in the animals eating ergots. So I've done a study to look specifically at the role of prolactin in gestation. First of all, you need to know how prolactin is controlled. It's a negative control. So the more of the neurotransmitter dopamine you have, the less prolactin. So what I've done here is I've given animals nothing, my controls, which are here, or bromocriptin. Bromocriptin is a dopamine agonist. So dopamine decreases prolactin, so I decrease it even more. So in this case, I've given it from day 70 to 110 of gestation. My nice control animal here, you can see the parenchymal tissue is pink, everything is wonderful, the fat layer around the extra parenchyma. Then you move to the animal receiving bromocriptin, and things are not so good anymore. All the fat inside of the parenchymal tissue, very poor development, a lot more extra parenchyma. So basically, if I inhibit prolactin in that crucial period, I also inhibit mammary development. Then I said, okay, days 70 to 110, that's a long period. I don't think you're hearing me well. Let me make this even closer. Okay, so then I will try to see shorter periods of time in gestation. Days 50 to 69, 70 to 89, or 90 to 110. So in these three periods, I inhibited prolactin with bromocriptin. Then you look at the good parenchymal tissue. What happens? 3 times 0 gives 0. So it's only in the period from 90 days to 110 days of gestation, when you normally have mammary development, that if you inhibit prolactin, you see a significant decrease. So now you know, from 90 days of gestation onward, prolactin is essential for mammary development. Some differences in composition, but the main effect is on total parenchymal weight. Okay, so prolactin is important. If I inhibit it, things don't go well. How about if I give it? Well, there's an early study in 1997 done by McLaughlin where they've given injections of porcine prolactin to gilts just to improve growth rate. And it was really nice because in their paper they had one sentence that was really important to me. Visually, they could see some mammary development. I'm really happy that the reviewers let that sentence in that paper, because then I did the exact same experiment that they did, but I slaughtered the animals, collected the mammary tissue, and looked at it. So indeed, they were right. If you look at same treatment of injections of porcine prolactin for 29 days, starting at 75 kilograms, either injecting 4 or 8 milligrams of porcine prolactin, look at parenchymal tissue. Doubling, you have twice as much of that good parenchymal tissue. And if you increase the dosage, not more of an effect. So there's a limit to how much of an increase you can get, but a doubling is already pretty good if you want my opinion. But you look also here, this is interesting. Look at the underside of the gilt. Normally this is straight, and you can already see, that's what they mentioned in the paper, you do see visual development in these animals. But the question remains, and it will be very sad because, as I tell everybody, I love to read murder mysteries. But if somebody would leave me at the end and just, tear the pages off where I find out who the murderer is, I'm not going to be happy. But I'm going to do it to you now. Because I'm telling you, yes, prolactin is great. Yes, injecting to growing gilts, they will have twice as much parenchymal tissue. But when we slaughtered these animals, we saw lacteal secretions. There was already some, I don't know if you can call it milk, but lacteal secretions. Okay, what will that do in the future milk yield when the sow is allowed to farrow? Well, I have no clue because I slaughtered them all. And I wasn't able to do another project after that, so that's something for young grad students to think of in the future. We need to know the importance of stimulating mammary development before puberty on milk yield later on. Okay, prolactin. Then for a while, there was no more studies using prolactin. Very simple. There was no more of the hormone available to inject in large enough quantities. So I waited a while, and then with my friend Russ Hovey in California, we decided, okay, let's use a pharmacological agent. So the dopamine agonist decreases prolactin. The dopamine antagonist will stimulate it. So this is what we've done here. So giving a dopamine antagonist in late gestation, in that crucial period, days 90 to 110, increased the volume of these alveoli in the mammary glands, increased milk yield by 25%, weight of piglets by 21% during lactation without a change in milk composition. This is great, my job is done, but obviously I'm still standing here and my job is not done, so it didn't end there. How to do this commercially? You will not tell every producer to go and give this agent at the end of gestation. However, a few months ago, a vet came to me to give a prescription because the most important period is between days 90 and 96. And if you do increase prolactin in that period, you will see these effects. So some vets are actually prescribing this agent to producers to stimulate mammary development. Anyway, if you were to do it commercially, what could you do? So I thought, can we do this through nutrition? Is there anything that I could feed the animal that will affect prolactin? Well, yes, there are some prolactinemic agents, and one of them is silymarin. Silymarin is an extract from a weed, a milk thistle extract. And in rats, it was shown that it does increase prolactin concentrations. And in cows and humans, it does increase milk yield. So I thought, this is great. Let's just put that in the feed and everything will be solved. Once again, I'm still standing here 9 years later. So I fed this to the animals in late gestation or lactation, did see some increase in prolactin, yes, but not enough to see any change in mammary development. So to do this through feed, we have to find some other ways. Or somebody will tell me, why didn't you just give more of this extract, milk thistle extract? Because economically, it wouldn't have made sense. If somebody could produce that in really large quantities, then maybe we could give more and achieve the goal. But right now, or in 2014 anyway, it was too expensive to try to give more. The third, in this case, not a hormone, but a growth factor that I want to discuss is IGF-1, insulin-like growth factor. We've given injections of porcine somatotropin because the mediator of action of somatotropin is IGF-1. So to increase IGF-1, we give injections of somatotropin. That was not something that I'm saying do with your pigs. It's just to understand how things are working. Is that growth factor important? And the answer is yes. So if we do give injections of somatotropin that will increase IGF-1 from days 90 to 110 of gestation, and you look at the animals you euthanize on day 110, significant difference in terms of parenchymal tissue. Some difference in terms of composition, more protein, more DNA. DNA gives you an idea of the number of cells. More RNA. Why is RNA important? RNA gives you an idea of the metabolic activity. So what I have now is more of the mammary tissue that contains more cells that are more active. Boy, that's really good. Now what should be done now is to look at the potential impact of nutrition to stimulate IGF-1. There are ways, and there's a company in Europe that was looking at it until recently, and you know how the private sector is, so they decided to change research focus, so they left things hanging there, but they had some good ideas and good results coming that, yes, through certain things, I know betaine is one of them, but there's other things that could be used to increase IGF-1 through nutrition, and that's something that would be very helpful. What do we know about nutrition per se? Okay, let's look at pre-puberty. First thing I'm going to do is ask a question. We know that feeding adjustments were made for the replacement gilts. More amino acids compared to energy, more calcium, phosphorus to help the legs. But if I ask a producer now, are you feeding your replacement gilts to maximize milk yield? Nobody can answer me because we don't know what that is. So I will give you what information we have right now. 20% feed restriction from days 90 to 202, critical pre-pubertal period. Significant decrease in terms of parenchymal tissue. Okay, you don't want to do that 20% restriction. Again, this was shown, and it's a nice study because they've done the restriction in 2 periods. So either before mammary development starts, period 1, or during the period, the other way, during the period of mammary development. And it's only during that period that you do see mammary development that there is an effect of the feed restriction. So it doesn't matter how you feed or what restriction you do to the animals before they reach 90 days of age. will not have an effect on their mammary tissue. But starting at 90 days of age up to puberty, then you have to be careful because that will affect the amount of mammary tissue. So you should feed them ad libitum. Fine. Somebody will say, well, why do you even bother with feed restriction? We're never going to do this anyway. Well, funny, but a couple of years ago, a producer came to me and said, I have a problem, which is something we have a lot in Canada, which is leg problems. I presume you guys have this too. But the leg problems we see are mainly caused by animals that are growing too fast. So then we get into these leg problems and longevity is decreased in the herd. So then I'm thinking, can we decrease the amount of feed in that prepubertal period without having a negative impact on future milk yield? So this study was done by Nicole Gregory, a grad student with Leanne Huber at Guelph and myself. And then she's done a feed restriction, again in the critical period before puberty. Control animals eating standard feed, 10% feed restriction of that standard feed, 20% feed restriction, or feeding more fiber in the diet, which obviously will dilute the energy of the diet. And that was fed ad libitum. Subsequent lactation, no change in milk yield. Boy, that's weird, because I know that the 20% feed restriction has a negative impact on mammary development, so that doesn't make sense. So then I went back and I looked at the feed intake of these animals. And genetics does wonderful things in terms of litter size, but also in terms of feed efficiency and feed intake. So what you see is that the animals in the study in 2004, the controls were eating 2.88 kilos of feed per day. But the controls in the more recent study were eating 3.5 kilos. So when you do a 20% feed restriction, you're not eating the same amount. So in the current study where things were okay, they were eating 2.7. But the older study, they were eating 2.1. So what I'm saying now is it's not the percent feed restriction that matters. It's the amount of feed that the animal is eating. I can tell you 2.7 is okay. I can tell you 2.1 is not. Don't ask me where in between is the threshold. I have no idea. Protein restriction before puberty, 14.4, 18.7. No difference in terms of mammary development. Feeding flax. Yeah, I have 5 more minutes, I think. I better move on. Feeding flax. Why would anybody want to feed flax? Flax contains oil. Flax seeds contain oil and also lignans, which have estrogenic properties. So when I fed this flax, I changed the fatty acid profile. However, I did not have any effect on mammary development. And then I thought, okay, the estrogenic properties of the flax was not great enough to have an effect. But then instead of using flax, I gave a phytoestrogen. So to have greater of an estrogenic effect, I used a plant source of estrogen, so genistein. So I've added this to a diet containing soya, and yes, there was an effect. 44% increase in the number of cells in parenchymal tissue. So if you have a way to increase estrogens, one way was through plant source of estrogen, it's beneficial. All I'm telling you here in gestation, don't increase energy too much because there is no advantage on mammary development. Energy is not the answer to the question. Protein intake, no significant effect in the one study that was done. Lysine effect, 4, 8, 16 grams per day, no effect on mammary development, but when they looked at the milk yield in the next lactation, 16 grams per day showed a tendency for greater milk yield. So then it leads to the idea of lysine. May lysine have an impact on mammary development at the end of gestation? So what I've done is I've taken the diet, increased the amount of soybean in the diet, so as to increase lysine by 40%. So a 40% increase in lysine, starting at 18.6, that was the estimated requirements of these gilts at the end of gestation, going up to 26 grams per day through soybean meal. Obviously, other amino acids all met recommendations. And obviously, increasing soybean also has an effect on crude protein. You have to be honest here. And other amino acids were also increased. But lysine is the one that was most affected with a 40% increase. And what you need to see, Well, this is easy. This is just body weight of the animals, obviously. These animals were gilts, so they had greater body weight gain with the lysine, no change in back fat. And what's interesting here, there was an effect on fetal body weight when it was corrected for litter size. But what I really want to show you is this here. You remember that we increased lysine by 40%. Then at the end of gestation, I go collect the mammary glands of these animals. And what do I see? A 44 and a 42. 44% increase in terms of parenchymal tissue, and 42 if you put it per teat. So basically, it's a 1-to-1 ratio. I increase lysine by 40%. I have a 40-some% increase in parenchymal tissue. This is amazing. This is amazing. And the composition was not altered, only total amounts. No change in composition. That was in gilts. But then I thought, okay, will multiparous animals respond in the same way? I've done the exact same study, but obviously the estimated requirements are lower in our multiparous animals, so 40% will be lower than for gilts. And then when I increase lysine by 40%, again by increasing soybean, so I increase also protein and other amino acids. If you look at growth rate, no change. So no change in body condition, meaning growth rate, which makes sense. Multiparous sows don't really grow as much. And no change in back fat, no change in fetal body weight, and mammary tissue, no change. This is really important. That's not published yet. It's submitted. You'll see it. Hopefully, I don't know if there are reviewers in the room, but hopefully it'll come out soon. So basically, gilts and sows do not respond similarly to an increase in lysine. That's important because as nutritionists, I'm not a nutritionist, I'm solely a lactation biologist, but it tells you nutritionists that you have to deal differently with feeding a gilt in gestation and a multiparous sow in gestation. So nutritional requirements do differ between a gilt and a multiparous sow in terms of mammary development. Most likely because the gilts are growing, and while they're putting weight on, they're also developing mammary tissue. So they respond to any stimulation through nutrition. And this is something that is really interesting. At the end of gestation, if you look at the parenchymal mass in the two studies that I've mentioned, so the most recent study, no, that's not what I want to say. Nope, okay, scratch. Yeah, the last two studies, yep, because in my mind, I call them lysine 1 and lysine 2, and my previous slides, I had written lysine 1 and lysine 2. I wanted to make it clearer, but I got myself confused. Okay, so yeah, those recent studies, in the gilts, the control animals had 1437 grams of parenchymal tissue. Treated with lysine, this is how much they had. Now the sows, control animals have the same amount as the treated lysine. So you already start with an animal that has more parenchymal tissue. And if you give more lysine, it doesn't go any further. So when you look at the control animals, you see a 39% increase in the parenchymal tissue, which most likely will give you an idea of why the animal doesn't respond. There's two things. Either there's a difference in the amount of parenchymal tissue at puberty, so you start with a different level when you give the lysine, or the animal that is a multiparous animal does not respond because she's just not growing, so she's not putting on more mammary tissue, she's not answering to a lysine stimulation. As I kept mentioning, when I gave more soybean, I increased protein, I increased other amino acids. So right now we're doing a study to try to separate these effects. So we have the same soybean treatment, but then we will also have an increase in lysine by itself, crystalline lysine, or lysine by including a whole protein, casein, and we don't have these results yet. Giving flax in gestation does not stimulate mammary development of that animal that's receiving flax, but her babies will do better. The mammary tissue of the female offspring from the animals receiving flax in gestation and lactation will have more parenchymal tissue. So that's a whole other aspect that could be studied. I'm way too old to start working on this, but there's a lot of young people here. So there's a lot of places where we could work to stimulate mammary development. And anyway, more work needs to be done. 2 minutes to end. Body condition, change in body condition. Being obese is not good. It's not good because it will have a negative impact on memory development. 36 millimeters compared to 25 millimeters of memory back fat will decrease DNA and alveolar cells and will also decrease milk yield in the next lactation. Fine. I don't think anybody cares about 36 millimeters and 20 some millimeters because that's over what we normally have in terms of body condition. Are there any changes in memory development with body conditions that we see normally in herds? I've done 2 projects, and what I've done is start with a similar back fat at the beginning of gestation. No, you cannot see the result already. And then we feed the same feed at different levels to achieve 3 groups of back fat. The low back fat, medium back fat, 18 millimeters, and high back fat, varied from 21 to 26. So I've created 3 groups of different body conditions. Now, when you look at the mammary tissue, one would expect that the fatter animals have less parenchyma, just like the obese animals. No, that's not what happened. The lean animals, can you believe it? For once, it's not good to be lean. I'm happy. Anyway, woof, I almost tripped over myself here. Anyway, it doesn't happen too often. Anyway, the lean animals, look at them. Less parenchymal tissue. So what is it telling us? If you have up to 16 milligrams, 16 milligrams or lower, then things are not good. But starting at 17 millimeters, oh, I said milligrams, millimeters of back fat, then things are okay. Being a little bit fat is fine. 21, 26 millimeters is fine. So 36 is bad. Anything lower than 16 millimeters is bad, which gives quite a bit of range in the middle where body condition will be okay in terms of memory development. How about if I change the body condition for a different reason? Because that difference is already present at puberty. So I start with animals that already have the same 3 different groups of body condition at puberty, feed them levels of the same feed throughout gestation, but different levels, to maintain these differences. Then you'd think, well, I'm going to see the exact same thing I saw in the trial before, because it's the same groups of back fat. The answer is no, absolutely not. Science is amazing, because you keep thinking something and you're proven wrong every time. Not every time, but very often. So now you look at the parenchymal tissue, no difference. Some difference in composition that are not really important. The animal is just trying to make up for the fact that it has less parenchymal tissue. But basically what I'm telling you here is feed intake in gestation is more important than back fat at mating for the amount of parenchymal tissue present in the mammary gland. So when you have an animal at puberty, you mate her, make sure that you're looking at body condition so that you feed her properly in gestation, because you can correct for a bad body condition at mating through feeding and nutrition. There's a negative impact of a gilt being too thin, less than 16 millimeters of back fat, but no negative impact of 22 to 26 millimeters of back fat. Overall summary, gilts should be fed to maximize their mammary development before lactation starts. What do we know? Before puberty, 90 days of age to puberty, you don't want to feed less than 2.7 kilos. I know 2.1 is bad. I know 2.7 is okay. Somewhere in between is the threshold, which I don't know. But 2.7 kilos is okay. If you have a source of phytoestrogens, yes, please, go ahead and give some. If you have a way to increase prolactin, it would be fine, but right now I don't think that we do. In gestation, from day 90 onwards, you don't want to overfeed energy. Anything we can do to increase prolactin, and it basically from days 90 to 96, there's like a week there that's crucial. Then it's beneficial for the milk producing and following lactation. Obviously, you don't want to feed ergots. It'll have a bad effect on prolactin, and anything you can do to increase IGF-1 will be beneficial. Gilts, any type of phase feeding whereby you could increase lysine in the diet via soybean, right now that's what I can tell you, by 40% will be beneficial. But what I'm also telling you is that this is only good in gilts. So if you have to invest energy somewhere, invest it in the gilts, not in the multiparous animals when you want to stimulate the mammary development. If you feed flaxseed in gestation and lactation, it will help the female offspring when it reaches puberty. And throughout gestation, you have to feed the animal to achieve optimal body condition. So at day 110 of gestation, you want to be over 16 millimeters, up to 26, then you're okay. And then I thank you. And if you have any more questions, I know I kind of went a little bit fast at the end, but I have a bunch of review articles. And so if you need any more information, my email is there. Feel free to contact me and I'll be happy to provide any more information you need. Thank you.
We certainly have time for questions. The mic is coming to you in the back.
You made a comment about the flaxseed, and it's been fairly well documented, and I think Dr. Rosero can jump in and make some comments about this, that the omega-3 is important in reproduction. And more specifically, the ratio of O6 to O3 is important in reproduction. And wanted to see if you had adjusted for that in your studies. And my second question is regarding the addition of soybean meal. It seems to me that by adding soybean meal, you're adding other amino acids as well as potential estrogen-like compounds. And to make a statement about lysine having an effect there seems to be confounded in your data. Can you address that?
Yeah, two very good points. The first one with the flax. Yes, we did see that increase, the change in N3-N6 ratio. But what it means is that that change in ratio is important for reproduction, but not for mammary tissue. So we did see it, and it had no effect on mammary development. So mammary tissue and ovaries respond differently. The second point is also very, very interesting. Well, first of all, I kept mentioning, more lysine via soybean, because obviously you cannot make a statement, it's surely lysine, until you have results from the study I'm doing right now, where we're actually comparing it. But one thing that's really important is soybean in itself may contain other stimulants of mammary development. And one study I've done when I was looking at the phytoestrogens, because soybean does contain phytoestrogens, and that could be something that would stimulate mammary development if I give more soybean to increase the lysine content. But what I've done, you can still hear me. I've done a study where I had a standard soy corn diet, then a very weird diet that had no soybean in it, as a really negative control of my soybean. Then I had my soybean plus genistein. So yes, adding genistein, altered the ratio of N3-N6 and had an effect on mammary tissue. But removing soybean had no negative effect. So the amount of phytoestrogens present in soybean in the diets that we're using nowadays is not enough to have an effect on mammary development. Obviously, that's decreasing, that's not increasing. But my gut feeling tells me it's not something else in phytoestrogens, but it's not a scientific proof like this. This I will only be able to tell you after the current results. But it's just to say that if you remove soybean, it doesn't have any negative impact on mammary development. So chances are it's not something present in soybean, but that's just what I think from that one study. Not you again. Your questions are too good. She's giving me a break.
I think it was the McLaughlin paper where you mentioned they could visually see the differences in mammary development that led you down this path. Do you have any practical recommendations on how people can evaluate mammary development visually? Because it's, practically we can't look at parenchymal cells in a lot of studies.
The picture I showed you is about as practical as I can get. So normally the underline is straight, purely straight. So when you do have some, well, some, it's not some, it was doubling the amount of parenchymal tissue. You see that, you start to see these, kind of bubbles. But I'm not sure that anything that is not as drastic would be easy to see visually. And sadly enough, I don't have another way to measure it, unless I've done an in vivo study at the end of gestation where we measured distances, between teats and the underlying and this and that to see if there's a relation to that and the amount of parenchymal tissue, so we could stop euthanizing animals. The answer is we need to euthanize them, but there was one relation between the underline of the animal and the base of the teat that did have some relation to mammary tissue. But I've never done that in a pubertal animal. So I cannot tell you if that measure could be used or not. So I'm really sorry. I can't help you much. That's basically my answer. But it would be nice to find a way to estimate that.
I have a question. Are you familiar with the Lachrican
Yep.
hypothesis?
Yep.
Do you feel that the time in which a young pig nurses, from the time it's born to the time it consumed its first colostrum, has any effect on the mammary development, and would that have affected any of your data?
I have no idea, because Frank's work is mainly on the uterus, so that hypothesis works really well with the uterus. I've never seen anything dealing with the mammary tissue. On the other hand, when you realize that in utero you do have an effect, so you think, well, if a fetus can positively react to estrogens from the mother, could drinking sooner, I don't know, growth factors or whatever is present in the colostrum have an impact? Personally, I doubt it. But it has never been looked at, so I cannot tell you. No idea. More? No, coffee.
Chantal, I will follow. Feeding a high lysine to that gilt, we can see the improvement in tissue as far as both DNA and RNA. Is that potentially a lifelong, or will those advantages dissipate before the next litter?
Boy, that's such a good question. It always comes back to when do you need to treat the animal to have most effects, and is something positive in the first gestation recurrent in the other gestations? I don't know. Right now I'm going to do a study where I will let these animals farrow and look at growth rate, but I had not planned on keeping the animals after to look at second parity because another scientist wants them. So I don't have the answer to your question, because obviously at involution, when you wean the animals, you have involution of mammary tissue, then it starts again in the next gestation. So is any beneficial effect you had either before puberty or in parity 1 still apparent and showing in the next ones? That's a crucial question. It's a crucial question.
Any other questions?
Yeah, so with your data, would it suggests that the 90-day time is the important time in the gestation? And if I could feed 2 diets, it's not easy on most farms, but if I could.
I know, not everybody loves me when I say that, but I gotta say what I gotta say.
Yeah. So if I could do that at 90 days, say I had 2 feed lines and I could do that, would there'd be just the benefit on the gilt?
Yep, exactly. Yeah, and personally, see, my next trial, I'm going to do it of day 85. I'm going to start it a little bit earlier because 90 is really rare. You really see a big steep slope, but you do have some slope before. So maybe starting it a bit earlier, even 80, 85, you would get more chances of it having an effect. But yeah, not the multiparous animals, from what I've seen in my study anyway. Which makes a lot of sense, because what's coming up at Midwest is I'm comparing the primiparous and the multiparous at the end of gestation. And the whole mammary tissue is completely different. So they don't respond the same. And from what we see now, it's really the gilt that is responding more, maybe because she's still in her growth process. Yep. To me, that's novel. I never thought it would be that, but then
So Paul,
that's what keeps me going.
if you don't have the second feed line, you could top dress.
Yes, you could.
Potentially.
That's the other thought that I had. Top dress was second.
Yeah.
When you're stuck, you're stuck. If it helps, but yeah.
Any other questions? Otherwise, please join me in thanking Chantel.